I started making my own exhaust manifold for the turbo setup, so piecing it all together out of stainless steel and making it all up with a separate flange, that type of thing, which was a really good learning experience, and I'm glad I did it. But it has, in the end, it did warp, so it's a known issue with this kind of thing. The warping is due to heat, so it warps in the welding process. And then I also had a problem where I think the actual flange didn't seat properly on the original studs. It didn't sit back far enough on one end, and I think then because it hadn't closed up enough, the heat of the engine and everything, it messed it all up. So I had it skimmed a couple of times and went from there. But really, yeah, I had to change it. So like I said, great learning experience, but we moved on. After the issues I had, I then replaced the manifold with a Kraken manifold. So you should probably know the name Kraken in Mark 1, Mark 2 MX5s. They make a lot of turbo bits and a lot for other cars now. So do have a look at them on Facebook. I believe they've got a website as well now, so give them a Google. And basically it's a cast manifold, so it should have far less issues than a stainless welded one. I did, however, make my own downpipe that connects the turbo to the mid pipe. This is all made out of stainless steel, so stainless steel 2.5-inch pipe, 63 millimeters, using pie cuts to do really tight angles, because you can put multiple pie cuts together and you can get a tighter radius than you can just out of a mandrel bend. So that was good. I found a few other parts, so that, again, good learning experience, and I've still kept that. I've modified that as I've gone along, and I'm still using my own downpipe on that, so that's really good. I didn't want too many videos, basically. I was getting lots of videos on this same topic, and I didn't want to make the turbo series really long. So what I'm going to do is I'm going to delete some videos and bring it all together in this video to talk about the manifold and the downpipe. There are chapters in this video, so it's going to be quite a long video. There are chapters in this video, so you can skip to whatever section that you're after, whether it's making your own manifold, making your own downpipe, or then putting the new Kraken one in, and then my final version 3 on the flange into the downpipe. So everything's here. Like I said, long video, but just skip to whatever part you want. After all my experience of making a manifold, making a downpipe, and the rest of the turbo build, I think the bit that puts probably people off the most is this section of it. So I think, and it's caused probably the most issues as well. So I would recommend that you start with these fundamental parts, and I think from there it's going to be a lot easier. So I would go the Kraken route. I would get a Kraken manifold. I would get a Kraken downpipe if it's available, and I would use the turbo that is built for. So those are your 3 key components that are going to mate up to your OEM parts, and they're tried and tested. The fitment should be good, and then all the other bits in the videos, like you're doing the wiring, your intake pipes, your intercooler, all that kind of stuff, is all the same. It's all in the videos. So after you've got those standard bits, I think you're really set up. I do think, and you might have a look on the Kraken website or send him a message. He is a really nice guy, that they are designing a new setup. So it looks like he's designing a new setup for the Mark III that takes a different turbo type flange. So that's interesting. You might want to have a look at him for that. So yeah, basically, I hope you've really enjoyed the journey that I've taken to get this far with my setup. This is all the information in one video, but my recommendation is go to Kraken, buy those fundamental bits, and then build it from there. After all the original parts are shown in this video, at the end there is a new part which is making up a new flange exit for the turbo, so basically to try and get rid of the boost creep issue. I've been successful. The boost creep is now all gone, so it's fantastic. So I can lower the spring on the actuator. It's now just running at 7 psi, and it easily holds just at 7 psi and doesn't creep up beyond that. So now I'll be able to use the electronic boost controller to increase that when it's tuned. So the new section is at the end of this video. So I've received my parts for my turbo manifold for my NC. There aren't many manifolds on the market, to be honest. There's a couple that are for a Mazda 3. I bought one of them by mistake, really, and it's got the turbo in the wrong position. It's too far back, so I need to get rid of that. And then you've got a Kraken option, It's really expensive. It's about £500, and it won't work with what I want to do because I need a flange like this one that I can get a nut on the back on here, whereas the Kraken one is has studs, and this is like molded into the manifold. So I'm going to make my own one up. This is stainless. This is 12mm stainless steel flange. That was from eBay. This is a turbo kit that comes with the flange, 2 pieces that you've then got to cut into wherever you want it, to be placed along your manifold. So it's good. So it's good that you can do it wherever you want. I've sketched out the holes for the flange on a piece of paper, and I'm just having a quick look to see. Obviously, these need to be cut down slightly. What I'm going to do is, obviously, these are straight. I'm going to take the same off each one and get that nicely matched up. And then on the end one here, because that one obviously starts to curve down, I don't think I'll take anything off this curved piece. I'll take all the meat off this straight bit, so that will match up to the same height as that one. So I've done the first one, so just using an angle grinder with a really thin cutting disc. Measured it up. I drew the manifold flange out here, and then I worked out the difference between the length I was getting as standard. Doing this one-handed, but you get the idea. That was that length, and then that's the length of the manifold I needed. I needed to take basically 8 millimeters. I've taken meat out of this this piece here, so I took 0.8 off. I just put some masking tape on there to see if I'm roughly in the right idea, and then I am. So that's the kind of thing that's going to be happening. Now I'm going to go on to working on this one. Probably take a bit of material off both sides, again, because you start getting into a curve down here, and it's probably best to take material off both. So we're going to try and carefully cut this. I put a piece round at the distance I want to cut off. Obviously this is curved, so it messes it up. I'm sure there's much more technical ways of doing this, but I just measured in the amount I wanted and then just made a mark with the point of the vernier. So I've cut all the components. Try to be as accurate as possible, but I have slightly got this middle one wrong, only by about 1 mil most probably, but hopefully weld will be able to take that up. I'm just going to chamfer the edges like they were before I did the cuts, but it's pretty much meeting up with the plan. So I'll chamfer the edges, I'll put them together with a bit of gaffer tape, or masking tape, and then and see what we've got. Hopefully it's fairly painless process, really. So I've made the last cut on the tubes, just tape those together for now. Continuing with the manifold, so this flange and this piece comes in the manifold kit. I've then just bolted it with some 8mm bolts to my turbo hot housing. And as you can see, the hot housing's got a circular inlet, and this one's got quite a big one. The flow obviously is coming in here and it's just hitting a dead space. So I'm not going to be able to reinvent the wheel, but what I want to be able to do is, I think this side I can take off quite a lot of that meat to maybe go all the way through, and this side I just need to blend that step. Try and get rid of it. So I've got a cheapo electric die grinder. This is actually my second one. The first one blew up, so you can take from that what you will, but just got this one. So I've got that Chinese carbide bit. So yeah, if you've got enough time and planning ahead, then these are really cheap. If you go onto like AliExpress, go on there, come in lots of different sizes, shapes. So all I've done in here is I've just gone round it with a black marker. So If I can just take that off, we can have a look. So there you go. So there you've got your round opening. As you can see, there isn't always meat behind, so there's a lot more meat this side. So that is chunky. So I should be able to take out most of that and really give that air a nice inlet. That side, obviously a lot thinner, especially there. So I don't really want to take any meat here. I'm just going to blend the edge. So let's just give that a go and see how that comes up. So after a little bit of grinding, literally probably 5 minutes, it's obviously rough at the moment, but I've just taken that line, taken it pretty much down to that line. A little bit of neatening up to do, obviously, but that's, you know, like I said, 5 minutes work. And as you can see, by doing this, we were just really helping the air transition into the turbo, and the flow should be a lot better. Okay, we're probably about, I don't know, half an hour in. So we had basically blended that at the start, and then what I've done here is I've literally taken away probably about that much meat, ground it out of the casting, blended it in. So I haven't just taken it from the edge, I've taken it all the way in. That edge is into the wastegate that also needs porting, otherwise you get boost creep. But at the moment, so I haven't done any sanding off or anything like that, but from half an hour ago when we had a round port, we've now got a nice nice blended port into the turbo. Also have some of these sandpaper wheels. Again, I use them for porting. I've got a couple left over, so just going to see if that brings it up at all. There you can see it actually has brought it up a bit. Again, this doesn't need to, you know, I'm being a little bit fussy as it is doing it, but you know, it's a hell of a lot better than it was before. The other job I want to do on this turbo housing is this is the wastegate, so it actually comes through from in there all the way through. So obviously when you've got excess pressure, you want that to come out of this opening, and this is the exhaust housing. What we've got here is quite a badly made wastegate setup, so obviously this meat is obviously making this whole lot smaller, and if you can't get rid of all the excess pressure gases, then you can get boost creep, and one of the known areas is to make sure that your wastegate is basically ground out to the right size. So I've drawn around my wastegate flap here. I don't really want to go that much further on this side, but obviously you can see I can on that side, and there's meat behind there, so definitely can sort that out. I got some tiny little die grinders which I'm hoping are going to work, because obviously it's quite hard to get in there. Don't really want to maybe get in there with a big one, so we'll see how that goes. So there we have it. I've opened up the wastegate opening. I was finding a problem when there was a hard edge here, when I was closing this on a really weird angle, it could snag. So it's not pretty, but what I've done is I've just taken off that hard edge of that corner, and then it doesn't seem to be, even when I push on this corner, it seems to always close now. So we're looking at removing this water pipe that goes to the expansion tank, because it's right in the way of any turbo setup you're trying to do. If you look at the back, if you follow it around and you go to the back corner of the engine, there's a normal hose clip like one of these, with the metal pipe going into a tiny little bit of 90-degree flex. So what I'm going to do, take the metal pipe out, and then I've bought a hose connector. This is 10mm, so the inner diameter of the hose, so it's 10mm. I was inside, I heated up this end in boiling water in a jug, slid that in. I'm going to put another hose clip on like this, and then I'm going to connect that in to the other hose at the back of the engine. So this car's actually been running in the last half an hour, so it's a little bit hot, but obviously before you take this pipe out, you need to depressurize everything. Let's see if I... There we go, so that's depressurized, so now there's no pressure in this line going in, and we can go about taking off this line. It's 13mm bolts on both of those. There is a clip down here holding this hose to this other heater hose, so you need to unclip that plastic clip, and then you can take it off the expansion tank here. As you can see, it's into a flex at the back. Not a very easy to get to flex, I have to admit. So let's have a think. So doing a little bit more on the water hose. So it's quite hard to see, but yeah, down the back there, I've done a, let me just zoom in, there we go. So that's a 10mm hose joiner. So the hose, when you take the metal bit off that goes along the top of the manifold, it leaves that hose on the other side, on the engine side, in place. So you just put the 10mm hose joiner in. The wall of the hose is a bit smaller than my hose here. So it's actually, it's this Jubilee on the engine side, which is a 14 to 16 size Jubilee. That goes on the engine, side, and then on this hose side of that joiner down there was this clip, which is a 16 to 18. So if you get those sizes, then I've bought a little kit because I was getting fed up of not having the hoses. So those are the sizes. That's clipped on down there. Like I said before, I've got an extended amount of hose at the moment because I don't know if I'm going to have to move the expansion tank across. So I'm just going to tuck it underneath the washer in a circle and then plug it in. So there we have it. At the moment, this is temporary. Basically, I've taken this bar off the heating rail because I need to get to this area to mock up the turbo, and it was completely in the way of the shell going on the other side. So basically I've got enough area now that hopefully when we drop this manifold, we can put the other one in place and work out where it wants to go. But anyway, so I've got that out of the way. So I've just run the hose down the side here. Like I said, I've just got a circle of it at the moment, just sitting horribly in the engine bay, just because I don't want to cut it too short, move this across, and then we'll have to buy another hose. So just temporary, but it gets all that out the way, and you can see the kind of thing you're going to do. I don't know what I'm going to do in the end. I might run it all neatly down the outside. We'll see. So I don't know if this is the right way to do things. I've never made a manifold before, but what I want to do is when I place the tubes inside the flange, I don't want them to go all the way through because I'd like to weld on the inside. So I'd like to set them back just a little bit so the weld could be placed there and not interfere with the flat of going against the head. So all I'm thinking is I've got some cardboard, and all I'm going to do is I'm going to cut out these holes in here, and then what I'll do is I'll place those bits once they're cut out inside here, and then place the tube on top, and then I know it's setting it back that far from the other edge of the head, and that it can be welded. So I'm just going to cut those out. So there we go, easy as that. Just cut it out with a Stanley knife, and all I'm going to do is when the weld bit goes in, I'm going to push that in there, and it's going to just keep it off the bottom, and there's easily enough there so I can then weld, well not me, but I can get it welded on the other side, and obviously all the way around here when the tube is sticking out. I think that'll work well. So we've got to the stage where we need to mock up the manifold on the engine. So I've removed the header, I've bolted on the 12mm flange plate, and what I want to do is, as I said before, I made these little spacers up, so it's all going to be a little bit difficult, but there is a ridge from the head to push those against, so I'm just going to slide those in. It's all going to be a bit of a palaver, so those just fit in there. That one didn't fit very well, but yeah, one more to go. I'd quite like to get that one out. So with those little spaces in, I'm pushing my manifold in, and then somehow you've got to hold it up. So I'm going to do a couple of bits of tape and hope and pray that it's good enough. Someone will probably come up with a lot better way of doing that, but that's roughly where that's going to go if I keep it in that narrow. Obviously you can't come up vertically because you're just going to hit everything, so if you're that narrow you're going to have to angle it. So this is probably the first time you're seeing the main turbo. This is basically a Saab turbo, so it's a TD04, but it's not a 13T, which is quite small, which is the Subaru one. This is actually a 19T, and I bought all the components individually. So this is a Saab TD04 HL housing, which has a Saab type exhaust exit, which uses an exhaust flange like this. So it goes on like that, studs on, and then your exhaust comes out from there. So what I liked about it is really quite neat, it's compact, and hopefully it should, because of the compactness, be quite nice. The exhaust exit out, it's got the wastegate in it, internal wastegate, and then this is a upgraded Mellet CHRA. So I believe it's had, so it's basically, it's still the Saab one, so it's the standard 19T Saab CHRA, but it's had upgraded bearings, and it's also got the billet wheel as well, billet turbine, so the lightness of that should help spool and things like that. So these are meant to be good for around about 300 to 330 brake horsepower. So like I said, I'm not going crazy. If I could have an everyday 250, 270, and then maybe a fun mode at 300, then that would be fantastic. But out and out power is not the goal, it's just to get a really nice OEM type feel power boost on a Mark III, and I think it can be done. So you've got that, and then with the different measurements, which I'll put up in some different literature and stuff, the turbine measurements and stuff, you find the turbine housing. I won't say what spec that is straight away because it is quite detailed, because what you need to get is you need to make sure that your turbine housing fits the right propellers, the right turbines. But the reason I chose this one was because it's got such a wide range of mounting positions for actuator brackets. And I have no idea how I'm going to do that yet, so I wanted as many sort of bolt positions as I could, so that's one of the reasons I chose this. So yeah, so I don't know which way I'm going to have it round yet. Some have it kind of pointing up like that, and they do a 90 and go like that. Other ones go lower and kind of push it past out like that. So who knows? We just got to get the got to have a look at this and see what fits. And I'm just trying to work out, you know, roughly where this turbo is going to fit. There's a lot of, it's quite obviously a heavy unit, and trying to hold it in place and try and work things out is quite hard. So there's some serious masking tape going on here. But yeah, it's looking, sorry about the camera work, it's looking like, because of how tight the housing is, I was going to try and run down there, but you're never going to get a hose on. So like some others have done, looks like when it's in position, I'm going to have to do a 90 here, 90 reduced, straightforward. And it's not looking too bad. I was just quickly looking, so I put the exhaust rear plate on. There's not a lot of room, but there is enough, I believe. So I'm just going to keep working at it, and then once I've got a rough idea, I need to make the extension piece from the actual turbo to the manifold shaped so it will fit onto the manifold part. And then I need to go through and tack it, and then obviously trial fit. Sorry about all the mess, can't bother to tidy up. So I want to tack weld things in place to start getting you know, a little bit better than tape. I've taped up the joint, I've left cut open 2 areas that I'm going to tack. I've got stainless steel wire and a normal MIG welder. And we're just going to tack. It's won't be pretty, maybe, hopefully maybe even the proper welder will grind off what I've done, but unfortunately when you're making a one-off like this, you need to get things attached, so it's going to have to get done like this. So just going to tack this in place. I'm in no way a good welder, so I'm going to get someone else to do that. Using my spot weld, pretty big, pretty gruesome, not pretty. But what I'll do is I'll ask the welder to see if he can die grind those off or do something, and then re-weld that section, because I don't really want it looking like that. But as I said before, when you're making up a manifold for the first time, you don't really have a lot of choice in these things. It's needs must. So this section comes in 2 halves here, and obviously I'm just holding the whole thing together with tape at the moment, so I'm going to put a spot weld down in that middle, so hopefully hold the 2 bits together and put it hold it to the flange on both sides. Probably put a little weld up here as well, just so I can take the tape off and start offering everything up. Nice little spot weld that holds all 3 parts together. I'll do another one on the other side, and then we'll start trying to fit this part to the manifold side of it. So now we're on to the part. So this is all welded together, well, spot welded together. Just clamped it there so it's vertical against the piece of wood I've got here. Like I said a minute ago, I've put some spots around this, so this is held together. So the next thing is basically to work out the cut of the bottom here. So I've got to cut this in a circular moon shape so it matches up with the manifold, and then obviously going to have to actually drill or cut out the hole into the manifold. But at the moment it's getting that curve right. So I took one of my little bits I made earlier and trying to basically use them to make this curve that's going to work. Don't know if it's going to work, but I'll grind that out, and then I think I'll use that as a place to start. Nothing's very pretty at the moment, so I've been working on this, trying to get this this curve into this piece. It's pretty good now. There, it's fine. The only thing I'm worried about is at this back clip there's a gap, so I've actually just texted a picture to the welder and see if that's fine to weld up. And then that's the part that you need to cut out in the middle. I think what I'm going to do at the moment though is maybe just spot this in place without cutting it yet, and just offer everything up, and then I can come back to it. So I've just tacked it just twice. Hopefully that'll hold it. The weight of the turbo is quite big. Sorry, the camera works terrible today. So yeah, so that is my tacked together manifold. Doesn't look pretty at the moment. Don't know if it ever will, but hopefully when it gets welded up properly, it will look a lot better. And don't drop it. So I've got my tacked together manifold on there. And this is, so I'm just putting it in with screws at the moment, but we normally have studs. There you go. I'm not going to wobble it about too much, but that's the position I'm looking at. Let's see. I've got space this side, so that's good. Straight hose coming in. It looks like I'm going to have a 90 pointing that way. Let's take the turbo forward. So, and then the awkward bit is going to be making up a bracket for the actuator, because the actuator is going to have to tuck under here and make up some kind of bracket to hold it. But the positioning and placement, you can see it's just behind that ABS box or whatever that is. I think it's the ABS box. So I can make something there for the actuator. So that's fantastic. And then the exhaust, I think I'm going to have to come out and then kink it towards the engine slightly, but I think there's a hole we're going to have to go down there. We will find out. Might have to take some of this lip off, which that's not too much of an issue. I think as soon as you take that lip off, yeah, should be able to get down there. So having a look at the manifold again, obviously you have this top bit. It's going to be welded on here, but as you can guess, the hole needs to be cut out for obviously the turbo gas, the exhaust gases come through. So it's pretty thick stuff. I'm using a die grinder, and even then I can feel that this motor's burning out a little bit. I tried to cut out as much as I could with angle grinder, and I did big holes with a drill. So I took most of them, quite a lot of the material out, but now basically just having to grind it out, and it's a little bit of a long old process. So I've got my manifold back from the welder. All good. Some nice welds. This one was I had a gap here, and luckily he was able to fill it with weld. That's good. Looks like I've either tacked it or the heat's pulled it down this end, but I've got a slight upward tilt to my turbo flange. I don't think it's going to be an issue. It looks like he sanded it, and I have put a ruler across it, and the flange is actually flat, so don't think that's going to be an issue. As in my other videos, you can see that I left, I put those spacers in to leave a gap this side. So I asked him to weld these, so it's fine, hasn't interfered with the outer flange, and it's welded those up, and it's also given quite a nice transition for the air, so that's all good. Happy with that. So that's ready to fit whenever I get around to it. So today I'm looking at the exhaust downpipe that I need to make. So it needs to go from the turbo housing and meet at the mid box. So we've got a few parts here. So let's just go through the parts. So we've got obviously the flange that bolts to the turbo exhaust housing. We've got it's a reducer that way, but actually this housing, my exhaust is 2.5 inch, this housing is 2.25, and it matches the inside of the housing, so there's no point making this bigger. So I got one of these. You can cut it to length wherever you want, but that obviously that's a 2.25 and it goes to 2.5, so that's that. I've got a flex point, a flex joint, just to give it a little bit of movement. Obviously the engine rocks and it just stops, obviously there'd be pressure on the back housing here of the weight of the exhaust and things, just allows it to flex. Half a meter of 2.5 stainless, so this is all stainless. I've then got multiple pie cuts for whatever angles I'm going to need, whether I need to just take it a little bit one way or angle it down a little bit, so we'll play around with those. This, I don't know what the standard exhaust is like because I don't have an standard exhaust. I believe this is it Roderson's or whatever, so it's got a what's it, Beat, it's got a Beat manifold, wherever it is, I can't remember, Beat manifold 4-into-1, whatever it is, and then it's got a replacement system all the way through. So on this system, the mid pipe has built in this side of this flex joint, so there's loads of 2.5 inch flanges that look like this, but their bolt holes are about there, and what I need is I need to try and match up to what my mid pipe is, because I didn't want to have to modify the mid pipe. So the only place I could get one of these, how I could find it with the right dimension, and we'll check it, was AliExpress in China. I think this was about £40–45 for the whole thing. Obviously annoyingly I don't need this bit, so I'll get rid of that, but I think these springs and this side is going to be what we need, so that's good. So those are all the bits. Oh no, one more. And obviously you have a lambda sensor that you're going to need to put in to a pipe somewhere. The Mazda is M18 by 1.5, so really cheap. Just get a stainless one of those from eBay or whatever. So I got one of those, and today what I'm going to do is I'm going to undo the manifold. I'm going to probably put a jack in to hold, or try and put something in to hold the mid pipe where it is at the moment, and then I'll take the manifold out, and then what I've got to do is bolt the turbo manifold on, bolt this housing on, and then start making up piece by piece my downpipe. So that's the plan today. So just under the car, looking at the front sprung joint where the downpipe comes down to the midsection. Like I said, I don't know if this is standard because I've never had a standard exhaust. I bought the car with this one on it. So what I've been trying to do is keep this all the same. I didn't want to modify the mid pipe. So what I was struggling to get was what looks to be 12 centimeter wide bolt holes. Most of these flanges that you'll buy, you'll think, oh, I'll buy a 2.5 flange like this, but it's completely different. It's much smaller because it's meant to be welded to the pipe, and these positions are much closer in. So I searched and searched and searched, and luckily I found this one as I kill the camera. I found this one on AliExpress, and let's see if I can show you this on the camera. It's all very hard underneath the car, but this is also looking to be right at 12. So I've undone the flange down there. Now we need to undo the manifold. 15 mil spanner. Be good if I undid it rather than doing that. I've actually been able to take this off a couple of times already and still use the same gasket, and it doesn't seem to have blown. So that's a positive. So I unplugged the lambda sensor from down the bottom. That is a Racing Beat manifold. And you're left with your gasket. You want that thickness on, and then I'll just take you off the thingy, and then down there, let's see if we can get a bit of light on that. Yep, so you've got your manifold that's going to go on there. The downpipe down there is being held up by a jack, and that's what I need to meet up with. So that's the plan today. So I've got my tacked up exhaust manifold. I've just put a couple of bolts in to hold the turbo housing on. Now we need to bolt that up. That's where the housing is going to go. You're obviously going to get quite close to this. So I am thinking, I don't really know what I'm thinking. We shall see. So I'm just mocking up, I've got the pie cuts, and what's good about pie cuts, if you don't know, is obviously you can get a 90-degree bend, but even a 90-degree really nicely made mandrel bend can't be as tight. So with all these different pie pieces, you can piece together very tight 90 degrees and things like that, or go right back on yourself. So what I find the best thing to do, just to help you, is eyeball them up and mark where you think the center mark is on the front. So basically then when you go to place them together, you are roughly in the right space. And then all I do is I use masking tape, start making up my bends, and it's trial and error really, so I'll keep doing that. What I got to do here is, because there's going to be quite a tight turn, all I really need is a small part of this tube. I'm going to cut the ends off just to have that bit coming out of the turbo exhaust housing. So I've just got my 2.25 to 2.5 adapter. This is the smaller end that's going to go into the turbo flange. Cut it off nice and close to where it turns, because there's not a lot of room. As you can see, I can't even, I can. That's at an angle, that's actually hitting the clutch servo. So that's the first thing to go. But obviously I'm not going to have this length, but just shows how much, really tight we are on this. So continue to work on this reducer adapter bit. So I find, obviously if you've got a mitre saw, I think they are, or whatever, and you can cut, straight through, great. I have built some exhausts before, so my eye is kind of quite good with doing it with a 1mm stainless cutting disc. And if something's round, get your masking tape, and obviously you can do it by eye, but as long as you start it by eye, pull it round, and normally it will match back up if you've got a good circle. But you can, you can eyeball it, and then all I'm doing is holding it and angle grinding it through. So that might be a little bit on the tight on the radius, I think there. Actually, go again on that one. So if we get it a little bit more into the, more into the 2.5 section of things, that comes round, and you can see all I've done is quite basic. Pulled it round. That one's not actually gone as well. You pull it round and you can pretty much get them matched up, and the rest of it is eyeballing. Probably going to be a bit warm. And then if you've got one of those deburring tools, fantastic. I don't. So I basically just get the curved side of a file, take the swag off, make it a little bit less sharp, blunter, whatever the turn should be. Quite a small piece now. That's hopefully, that's a 2.2. Should match up to whatever we end up doing. So let's go back to the car and have a look. So we're just going to offer that up to the back of the turbo. See that fits in nice and neatly now. I've now just put all the pie cuts I've got together just to see what angle I get. and I've now taped on this little adapter bit. So let's see how that's lining us up. So yeah, it's pretty, now angle us in any direction I want. It's just a shame I'm going to be out of the pie cuts. You have to be a bit careful because you actually do need to send it out a little bit from the actual manifold. But no, not bad at all. This straight section isn't representative. I haven't, it's not cut to measurement or anything. What I'm doing is I'm getting this part, which is going to be this part, and then obviously you have a gasket, but you've also got to have a lambda. So you've got to have your sensor as well, which is this sensor boss, and I just want to get an idea really. So it's 6 centimeters back from the front edge of that pipe. So if we mark roughly the same, that is roughly where our bung is going to go when we finally do it. So what I wanted to do is make sure I know how long a section I need here to get that bung in. I then want to put in the flex at some point. So if I give that another no, 3 centimeters, cut it there, and then probably that will go on something like that. You can get your O2 in, that's there. I'm not setting the rotation of this yet. The piece on the mid pipe does move, so it's not necessarily critical, but I can see just with how much space there is, there may be a better orientation for it, so we'll come to that. So looking at doing, before I make this too small to really hold and things, it'd be easier if I cut the hole for the sensor. So this is 22mm. This is a 22mm hole saw, just from a generic hole saw kit. In stainless, it could burn out pretty quick. I'm hoping I get one hole out of it. The pilot is a 6mm hole, 6mm drill. So what I'm actually going to use is a cobalt drill bit for 6mm to do the pilot hole, and then I'll come in with the actual hole saw. So that's the plan. So that's the pilot hole. It's not quite. That's a bit better. Right. Okay. Now comes the hard bit. Trying to get through stainless with some pretty average hole saws. So my hole didn't go as well as I planned. I broke my 22mm bit, so it judded a little bit, so I've got some marks, which is a bit annoying. I've then filed it out, it was nearly done. Then your O2 bung, be nicely welded around the outside. I don't like it when I've messed things up, but you know, it's going to work. So now I need to cut this bit off. Bit, so pretty good. I have remembered that most of this is going to have exhaust wrap around it anyway. So if you can do it neater, please do so. What I'm going to try and do is, if this setup, the way the relationship to the sensor and the position of these bolts works on this one, then there's no reason why it shouldn't work on the new manifold. So what I've got to do is get the relationship right, and then tack this and then get it welded up properly. So that's what I'm going to do. I'm just going to copy the relationship to get that right. So I've got the bottom joint tacked to that pipe. The old sensor was pointing upwards, so that's where I've placed it. So I've just got that in, as you can see there, and now I've got to mock the rest up to the back of the turbo. So today I've run out of pie cuts, so it's a very restricted area, you can see here. And what I was doing, I was coming straight out of the back of the turbo and then pie cutting downwards, but that was taking me really close to this clutch cylinder. So what I've done, I don't know if you can see, I'll turn the camera this way, is I've used one of the pie cuts straight out to kink it that way, and then I've done the pie cuts. You've also got to be really careful because you're very close to the manifold on that side, very close to this lip down here that a lot of people get rid of. I might just tump it to one side a little bit, but at the moment I'm trying not to get involved. So I've run out of pie cuts, so got to there. If you can see down there, focus down there, so that's the flange on the other end. So I've tack welded the short straight section, which will take the sensor, and then I need some more pie cuts from there. So I'm looking to do a couple of pie cuts to turn that up. I'm then going to put the flex in, and then I'm going to basically make this connection. So I'm going to have some more pie cuts. I think it's going to have to bring it around and this way, and then some more pie cuts go that way. So it's a bit fangled, but the great thing about having all the pie cuts is you can just send the pipe any direction. And when you're talking about, you know, that, you know, just kinking it off that way has given me a good, oh no, when I say good, it's a finger there. I'm going to wrap this in exhaust wrap, try and help a little bit as well. But before it was, you know, we were talking mil, and I wasn't happy with that. So that's where we're going to stop today. We're going to lose the light soon. It's December and pretty cold, but luckily it's been a nice bright day, and I've just been able to get that crack on with this. I've got to take it all apart, put the other exhaust back on so I can drive home. So I better do that. So we're back on the turbo build, looking at the exhaust downpipe again. It's a week on from last time. There's ice all over the floor, but things need to get done. So what I found last week is when the reducer piece that I need to go to 2.25 into this, when I tried to weld it to the flange, I'm not a very good welder, and I blew a hole in the reducer bit. So I had to order another one. So I've just made up another, just cut down the reducer bit from the 2.5 to the 2.25. I've been able to make it a little bit shorter, which is going to help with the turn hopefully. That's actually now tacked on there, so I need to get back to making the downpipe. Like I said last time, I've got a kink, so when it comes out, it kinks away from this slave. And what I'm going to do is just continue piecing that together. I've got more pie cuts, and I'm just going to keep piecing that until I meet the bottom bit, and I'll show you the results as I go. So this isn't an easy job, so that's not necessarily downpipe there, that's just pushed together, it's not necessarily where it's going to be, but it's giving me an idea of where it's coming up, and I've got to meet this other pipe here. I was finding a few things were moving, so I've just tacked this first pie cut onto the reducer section. So that's kind of what we're looking at the moment. It's quite tricky, really having to play with things down there to try and miss the inner manifold exhaust exit. So just keep playing, and we'll see how we go. So I've been playing around with this, and I do think unfortunately I'm going to have to take some of this lip out. So I'm going to take a grinder to it, try not to go past the spots, so I want to take the strength out of it. But if I can take the excess off, then hopefully it'll give me a little bit more room. The black line there represents what I'm going to try and grind away. So like I said, I don't want to go into the spot welds because that would take away the strength of the panel, but I'm just going to try and take off that edge up to the top, blend it into that bottom bit, and hopefully that will just give it that little bit more room that I need. So I just used a flapper disc on an angle grinder and just softly feathered that edge back. Just going to see if it's enough, and obviously it needs to be painted. I don't want the rust getting through on that, but yeah, so that's how much I've taken off. Not too much. I don't want to take off more than I need to. So sorry that there hasn't been many updates throughout the day. I've literally just been fettling, trying to make this fit, and there isn't many hours in the day when it's middle of December, but I think I've done it. So obviously done the kink out of the top bit. I've nicely missed the, oh, was I lose a tool? Nicely missed the inner manifold. Got a gap to the clutch. I've got a flex in there. Flex goes down, it kinks slightly across, welded to that flange, and then it meets up with the mid pipe. So it's one of those trial and error ones. I'll take some video of it when it's out, but really you just got to buy the components and piece it together and make it fit. I took a little bit more out of here, probably going to take a little bit more, but it's still got all the strength and spot welds in there, so not a problem. So the downpipe has all been welded up. Lots of pie cuts up here. I think I counted something like 17 welds just in this point. The flex joint, it does actually, if you hold one end, it does actually flex slightly, so that takes some of the shock out of it going into the turbo housing where it's mounted. All welded up, bungs in. This bit's ready for like the mushroom, I don't know what you call it, the gasket that goes on there, just slides on there and then bolts together with the other bit. So happy, yeah. So all welded up, and the next thing I need to do is do some heat wrap on this, and I'll show you that. Okay, sorry about the camera work. I've forgotten my tripod. Right, okay. So we're going to put some heat wrap, exhaust wrap on the downpipe. This is what they call titanium. It's mainly about the colour. I think it hopefully will semi-match my turbo blanket. But anyway, it's meant to be from like volcanic rock and all this kind of stuff. Who knows? It frays really easily, and these are horrible and itchy. So I've put it on this just because I want to cut some of these strays off, and I don't want it all over the carpet. Okay, so this is the top. So what I find best is when is the edge. So the edges at the bottom is to actually do it upwards, not that way, that way. What you have is stainless steel tie wraps, metal tie wraps. You could either get these, because you're not going to need that many, you could either sort of get 5 of these in a kit when you buy the wrap, which is probably the best way to do it. Or you can, I can't remember where I got these, I think these are, one of these is from someone like Screwfix or Toolstation, because electrical conduit is now secured with stainless ones, so you can get these. So these are 3 or 4 stainless cable ties. So let's so I'm not going to go into this bit, I'm just going to start it. So they do say to just tuck the end, but I'm going to go right over it, so it should be fine. It's all about pulling it tight, getting it tight and pulling it, so you've got a good start going fully around the bottom. Then you're going to start coming out, and I'd say you're going to do about a half overlap. Like that, and it will start to move. So at some point, you've got to put on one of these ties on the bottom one. So they literally just slot through and start grabbing. There is a special tool you can buy to do these up tightly. Guess what? I don't have it. all I find to do, all you can really do is just kind of grab it and try and pull it as tight. It's probably going to move a little bit. You just got to try and get it as tight as possible. And then what I find, I haven't done one of these for a while. Let's see if I get it right. If we cut it off about there, you can bend, maybe a bit further, bend that back, and you can tuck the sharp cut into this joint piece. So let's see if I can do it on the first one. So cut that off, bend the piece back, that one has just about tucked in, and I've tucked it back in so there's no sharp edge. So once you've got that one fixed, then you can start wrapping the rest of it. So like I said, about half. Not always the easiest of jobs. We need to get it like that. So that's, you know, looks pretty smart. Not a lot of effort. Don't know if I've got enough to do the bottom now, but we shall see. And then the open bit's there. I'm getting to there, and then when you cut this, it's obviously going to fray. So you want to leave enough that you can then tuck the frayed bit. And obviously, if you tuck it on the rear side, that's probably a little bit neater than anywhere else. So I'm probably going to want to tuck it about there. Right, okay. Get another one of your cable ties. If I knew where the top was. Right. Okay, so tuck that right in there. Nice and tight. So what you need to do is you pull on that and kind of get something that doesn't hurt your finger to. Whew. So that's as tight as I can get it. Right, so see, it still moves. Right, and then we need to chip it off, clip it off. So that's about there. Bend it, and then tuck it. Wasn't really bent in the right place. It's going to look a bit messy now. Right, there we go, that's the tuck. Squeeze. Yeah, kind of worked. Play around with it, neaten it up. That's exhaust wrap done. You could obviously do another securing piece. I might do another one in the middle, but obviously the neatest for looks wise is just one on the top, one on the bottom. So I'm going to do the next bit. I've shown you how to do it, so we'll skip that on the video. Welcome to another turbo video. I've started off showing you it all in bits, but there is a reason behind this disarray. I've been having a few issues. I had a really cheap turbo hot housing, which is this one. I'll be showing you a comparison in a minute. I'll be having a few issues with it, and I've upgraded it to a better quality aftermarket unit. So let's have a look at that, and I'll show you the differences that a few extra pennies can make. So these are the two hot housings. This, obviously by the colour of it, is the used old one, and this is the replacement one. I'll show you, this is actually, I couldn't get hold of it anymore, not that I wanted another one, but I'll show you where I got that from. And this is a Mamba unit. Most of you that know about sort of aftermarket turbo bits will know about Mamba. They do whole turbos, they do stud kits, they do all that kind of stuff. So that's fine, but let's have a look. So this was the one that was on the car. And one of the issues I've been having, a couple of the issues I've been having these studs, I think I've shown before, these studs work themselves loose, so I've actually dinged them to try and stop that. But one of the areas where this blind one is in, I was obviously having to try and ding this side, but it's still getting a little bit of loose studs and things. So that is something I've amended on the next one, which I'll show you in a second. And it's the same for these as well. But the big problem has been this wastegate. When I first got it, that was more like a sort of moon shape or that kind of thing. So I actually had to grind that out. And then because I had to grind it out, this flapper isn't actually very big, and it can actually, at certain bits, get caught. See there, it's not, it's catching before it's closing, like that. Also had another thing where obviously this has a rod that goes through. You can see the quality of it. So this was a rod that's gone through. They've bent the rod. They've then flattened the rod and put a hole through it to attach the flapper. There's then also an inserted sleeve in the housing that a rod goes through. And at one point the sleeve actually came loose. So this whole thing was moving outwards. So again, I had to, the only thing I could do was ding the housing over and try and stop that moving out. But I do still wonder when it's hot how that's working. So we think maybe I've been having a little bit of wastegate stick at certain things, so that's something you want to get rid of. So wasn't happy with this design. It's not great. So what I've got here, just to give you a comparison, because that's all the best way to do it. So then this Mamba unit has got a proper forged rod, so the whole end here is made for it. You can tell that the flapper here is much bigger. The hole straight away doesn't need to be bored out. So this is where you'd get, if this is too small, that's where you'd get boost creep, because you can't get rid of the gases. And a lot of people then have to open this up to get rid of boost creep. But obviously Mamba straight away, it's a better made item, much better setup here. And then as you can see, like even the size of this rod, much thicker here. And then another really nice quality bit is that this insert has a recess in it, and then they've pinned it, so that cannot work its way out. So that is a nice action there. So that's another thing that's been great. And then obviously to try and mitigate these stud issues. So these aren't the studs. This came with a stud kit. This came with a Mamba stud kit, stud and nut kit. But the studs, they would screw in here, but then only go about halfway into here. So it's how to fix in here. They give you a nut and spring washer kit, which is fine for working off that end. But what happens is these heat up and these work out of the actual housing. So what I did is I ordered Fiat Porsche M8 studs. So I'll have to get the specs, but I think there's 16mm threads on either end and maybe 9 shoulder in the middle. But anyway, what I wanted to do is, as you can see, they're poking through the other end. So what I've done all the way around, I've got them. So I've got the same length here, which I think is 25 mil, and then get them sticking through here. And then what I've had done is I cleaned off the housing a little bit, and then just had a spot weld put onto every single one, so that shouldn't work loose. And then what I've done, the reason I wanted it to stick out is if I ever break this stud or we get an issue with a thread, I can just angle grind through there. And that will take the weld off. I can pull the stud out, put another one in, get it tacked again. And then what I've done is these are the same, so they've protruded through, just a nice little small tack on those. You can see where I've cleaned it up, ready for welding. And then with this dead end, with this one, what I did is put the stud in and then drilled through. So I drilled through the housing and then drilled about halfway into the stud, and then put a pin in it, so that one shouldn't come undone either. So I think that's a much better setup, getting it done from word go, and I'm really hoping that's going to be a lot better. So just having a quick look, they're obviously out of a completely different mould. They're both 6cm housings, but looking at it, obviously I don't know the thickness of the casting, but this whole section looks thicker. I do hope that they are going to match up and fit, because basically you want that edge flange, that to be the same as that, and it's, I think it probably is actually. So that's great. So that's the reason I've done it. Replacing that one, putting in the nice new Mamba unit. Obviously it comes normally with a clocking dowel like this one did. They just pull out, get a pair of pliers on that, pull it out, and then you can clock the turbo wherever you want. So I did a tiny little bit of porting here when I already had the studs in and I couldn't really do it there. This hole was much better than when this one was first done, so I think that's pretty good. So yeah, so that's great. So that's the reason I'm doing it. Let's get this back together, and hopefully there's going to be an improvement. So the process of putting it all back together, what we need is a new gasket to go on there. Okay, so you put your gasket on there, nice new gasket. Make sure your surfaces are clean. They've only been done recently, so there you go. Hopefully all lining up in the same places as before. Let's get the exhaust bit on, make sure we can get it on. Sometimes it can be a bit tight. Oh, straight away, really nice fit. So exactly the same positions as it was before. So I'm not going to make you watch this, but obviously there's 3 nuts onto the back flange and 4 nuts on the bottom side of this one. So let's get that done. So I've got all these, I've got the exhaust flange done up, I've got the flange to the manifold done up. So then obviously lowering down the cold housing with the CRH in the middle. I've done up the oil drain on the bottom, and obviously that's sliced together. We've then got the clamp for the middle. Spin it around like that. And then obviously now you've taken out the pin, you can clock your turbo wherever you want, but obviously mine's defined by my oil drain. So let's have a look here. So I've done it up mostly, it's still a little bit slack there. What I need to get on now is the actuator that goes on the front here. I think I'm going to have an issue with the length of this arm. I'm going to need to chop some off to be able to bring that arm back, because this lever is in a slightly different place. So I've got to do those front bolts. These ones go in, they're very short, only about that long, so I put them in with screw lock. Feed that down in there. The bracket I made to line up. There we go. Get yourself some ratchet spanners, very useful. Okay, so it's close on this arm, let's have a look. So what you need on the arm is, what you want is preload. So when you're attaching your actuator arm, when you've got the pin there, what you want is to actually pull the actuator about half a turn back. So you actually have to pull the actuator out slightly to go onto the wastegate arm, and that just keeps it back. Like I said, I haven't got much thread left on this, so that's about the maximum I can do, and it's not enough. You get that, so this arm, the other one was straight down, so I had leeway, but this one is tilted back, so it's shortening this arm. And what you really want is, you want the arm to be half a hole backwards to put preload on this. But as you can see, this is literally just going straight on, but this is bottomed out, so I'm going to have to shorten the threaded rod inside here, so this will then go backwards. Yeah, or maybe maybe it's worth doing now. See if I can actually get around it. So I did have some tools here good enough to shorten the rod on the actuator. So instead of having to space her out and it not really working, I've been able to shorten it just enough, and it looks like I'll have half a hole overlap to put preload onto that. So now, as you can see, let's get you there is sort of half a hole's worth of overlap, so I'll have to pull the actuator rod out slightly to then go onto that rod, and what that does is just put some preload on that to keep that wastegate shut when you don't want it to open. So that's always a good thing to do. So pop that on, and then a little circlip goes on there, and that's that rod done. So the actuator's all done. That's looking really good. So need to get the boost pipes back together. So we've got one that goes down to the blow-off valve down here, which is that one. That goes straight into the turbo, that's your feed, and then this bit goes to the air filter. So always a bit of a jiggle to get it all to go together. Let's give it a start, shall we? Nothing horrendous happened, so sounds good. So took it out for the first drive, and for whatever, well, I'm basically not making full boost. It's boosting to about 7 to 8 psi, and before it was on the dial it's about 10, but on the ECU it's about 11, I think, 10 to 11. And I also noticed it's quite hard when driving to try and pay attention, but also it looked like maybe the boost curve fluttered a little bit on the boost gauge, which kind of indicates that maybe there's not enough preload on the wastegate and it's opening prematurely and wasting some of the gas. So what I'm going to do is, obviously I was having an issue trying to shorten that rod. I have shortened it and put the lock nut back on. What I'm going to do is I'm going to take that lock nut off and put more preload onto that rod and see if that improves the situation. Sorry for the short clip of the boost, but my videoing went a little bit wrong, but you could see from it very quickly that it wasn't making the correct boost of around 10 to 11 psi. It was falling short. So obviously you've got the actuating rod down here, and what you can do, is how I believe it's said here, is I had a green spring in my actuator which says with rod movement, and what I think they mean by rod movement is actually the preload, I think. So basically the 3 mil displacement of rod will be defined as the spring pressure. So I think if you give 3 millimeters of preload, you're going to get supposedly a PSI of 7 PSI. If you put a preload of a lot further, of like 10 millimeters, you should get 10 PSI. Well, I tried that. I put a lot more preload on it, and I still wasn't reaching 10 PSI. So the only little annoying thing is the jump up in spring is quite big. So from the bottom one it's only 5 to 7, but then it's 7 to 12. I think my car got tuned at around about 11, so 12 is pretty close. So what I did, because I wasn't having there's no other way of trying to increase the boost really. Obviously I can go back and get it remapped, which is something I will probably do, because what I had before was I had obviously the green spring producing about 7 psi, and then I had an electronic boost controller that would trick it to run higher boost. But I think what might have been happening is even though it's tricking it to a higher boost, I think throughout the boost curve, I think it's still, the wastegate still might have been opening a little bit and wasting boost, because what I've done, and the reason I think that, is I've now put the yellow spring in, and I've put it in with only about 3 mil, half a hole, about 3 mil of preload, and I am making 12 psi, and it boosts so much harder. It's like the wastegate is being held closed better all the way through the pull, not just up to the maximum psi. So I think maybe I was getting some boost leak issues before, but yeah, so now it's boosting at 12 psi. I want to get an AFR OBD. I've got one. I tried to connect it and couldn't get my phone to connect to it, and I just want to make sure it's not running lean. Doesn't matter if it's really running a little bit rich, because that's safe, but if the engine runs lean, then that's a bad situation to be in. So I think it's okay. I've driven it on the 12 psi, and yeah, wow, it really does pull really nicely. And like I said, it feels like it pulls harder up to that as well. So yeah, I think there may have been an issue before. So all I'm going to do is I want to be a little bit safe on this 12 psi. So the way I'm going to finish this up, and I won't show you because I've shown you the rod movement and stuff, the next spring up is so much harder than this that I think it will keep the wastegate closed even with a little bit less preload. So what I might try now is maybe another turn back on the rod and put that in, and hopefully that will keep it, because it's around 12, maybe just slightly over. So if I could get it back to like a constant 12, because what I don't want to be doing is over boosting, because it's not a forged engine, it's a standard engine. I think I'm alright, but you know, it's better safe than sorry. So yeah, so it's worked really well. Haven't had any issues with the actual housing, obviously, other than it changing the boost. So do be mindful if you ever you're changing the turbo components. They are obviously going to affect performance and the way it works, or how it boosts, and you may have to go back for another tune. But yeah, so far really happy, and glad it's all worked out again. So here we are, another turbo video. I apologise for the mower next door, but got to get on. So this is a turbo video. Unfortunately, I've been having a bit of an issue with the stainless steel tubular manifold. I knew this when I built it, that sometimes you can have issues with it, but unfortunately it cracked on some of the welds. I had it re-welded, and even though it was bolted down to a plate, once it was taken off the plate, it bananaed, and it's been milled 3 times already. So the flange is just getting smaller and smaller. So unfortunately, I put it all back together, and it's blowing. You can hear the blow. So really just got to redo this, and I've bitten the bullet and got a Kraken cast manifold. So I'll be showing you all the bits, showing you me putting it back together. So I've got a new Kraken manifold. The unfortunate thing is the way it comes up, it has a different, it's got the same flange, but it's got studs actually in the manifold, and one of it's not compatible with this hot housing. One of these hot housing bolts, basically this has studs going that way, the new manifold has studs going that way, and one of the bolt holes in the housing is closed off, so you can't get to it, so it's blind. So basically I've got I wanted to keep the same turbo cold side, the same TDO4 19T CRHA, and basically just change the manifold, the hot housing. But obviously the new hot housing that I found that should take this CRHRA has a different exhaust. It's probably going to be in a different place. So yeah, we're just basically going to mock up today and see what's going on. Obviously the first thing is to get all this lot off, so that's my first job. So I've managed to get all the old turbo setup off. Wasn't the easiest, but I got it off in the end. Some stuck nuts and things. So this is the new Kraken manifold. Let's see if it fits. It does, just like you would expect. So I'm not putting on for the last time. This is all just mock-up, so I'm just going to use some standard nuts. So I've got the manifold on, and I've got the new hot housing on, which has can take studs coming up through it. One of the things I've noticed is that the manifold is an M8 stud, and the holes in the hot housing are M10. So if I'm going to use this setup, I will probably drill out the manifold and put M10 studs in there, put a new thread in there, because that's not going to work. So the first thing I'm noticing is quite a bit further away from the cam cover. So yeah, so let's have a quick, I was thinking it's going to be roughly in the same place. So that feels like it is. it looks like I might have a bit of an issue with the turbo oil drain. So that's something something to consider. So there's the oil drain coming out. Obviously you can swivel this a little bit, but you don't really want to be putting it at such a massive angle. Yeah, so that's a bit awkward, so I'll have to rethink that. And then obviously the main bit's going to be this exhaust here, so that's the next bit to have a look at. So I don't know if you'll be able to see this that well, but I've taken off the clutch master. There was no way with this configuration that that was going to work. My other option was to completely change the turbo and go for like the 2860 turbo, but that and the whole exhaust, that's probably going to cost me like £1,000 minimum. I don't have it. So what I'm thinking of doing is basically this clutch servo goes in like that, so with that horizontal, that's the top bit, and it's this bit that's getting in any way of being able to do some kind of exhaust. So there's nothing, let's get that up there. There's nothing to, I can see, to stop me rotating that. So if I can rotate that and place it like that, then it does look like it will miss. So what I'm going to do with the help of a friend is these studs come out of this, and what I'm going to do is make up a plate behind this, a thickish plate, and what we're going to do is countersink some bolts in the plate and basically rotate this like that, countersink and screw into this, so that will hold this to the plate, and then tap the plate and put these studs in the original positions, because you can't just drill new holes because it's really thin metal and it's tubed between the layers to give strength, so you really want to go back in the same way. So the place where the rod is going to be exactly the same. We're just rotating this. It does mean that this is going to be further out, so in theory the rod needs to be longer. There is some adjustment on that rod, and when this is out you can actually get a 10mm socket on the end and unscrew it a bit and get some of the length back there. So I haven't been able to get back quite as much as I'm probably going to have in the plate, but I have got back about 3 to 4mm of extra travel, so I'm hoping that's going to be enough. So when all is said and done, that would then be going in like that. There's enough flex in the metal pipes to be able to change it, and then the existing holes you can see there, the big ones, will still be used by the plate and bolted, nutted from behind. So no, I think that's a really good way of getting around the problem. So after last weekend's machining effort, I now have M10 studs in here. So yeah, so they're all in to match the hot housing that I've got here. So obviously you put a gasket on, hot housing, and then this is all just mopping up, and then hold that in place. And what we're looking at is to get this exhaust mopped up today. So pushing on with the exhaust, it is ridiculously tight, so that's not in properly, pushes back. That's the kind of space we've got. You then have the issue you have to miss the Kraken manifold, so there's a gap there and there's a gap on the other side. So basically what's happening is I'm kinking it as we come out, and then it's pretty much curling back on itself underneath. And then if you're going to be able to see, I've run out of pie cuts, but basically, let's see if I can get you down there. Basically that, I think with about 3 pie cuts, should meet up with the angle of the other pipe. So I've just ordered 5 pie cuts. I don't want to be left without just because of that. I might have to take the downpipe, this bit, down, reduce the length of it a little bit to give a bit more space for the curve. But hopefully that is very close to meeting up where it needs to be. It's so tight. So there's obviously going to be a lot of heat. I was hoping to put a heat shield in here. I don't know if there's enough space. This is not the best, but we'll see how it turns out. So I'm going to be finishing off this piece. So basically this was to rotate it. So this is countersunk, and I got some M8 countersunk bolts. So just seeing if this all works okay for the first time. Like I said, those are the original studs, so just put those in, and I'm now looking to obviously make this prettier. So that slots in there, so that's going to go in there like that. I'm now going to take off these edges and things, make it a nice shape, and paint it up, and that has rotated the clutch master. Just a little thing, but I was finding they're W4 clamps, but they've got A2 bolts in them, and the threads have gone because A2 is very soft. Off top, so what I've done is A4 is a step up in stainless, and A4 is about the same quality as a 8.8 bolt in zinc. So just bought 5 of those, and just going to replace the bolts on these clamps for some better ones. So just little things, but not very much money off eBay, and stops you hopefully stripping the screws. So I've got the bracket that I made up, I've cut it down, I've painted it to make it neater, and basically I need to attach the master with some M8 countersunk bolts, putting a bit of screw thread on there, a bit too much. Let's see if we can get rid of that. There we go. And then Allen key and countersunk, so they go flush when it goes up to the bodywork. So do these up nice and tight. Hopefully won't be needing to get to them for quite a long time. It's taking quite a lot. So once the manifold's out of the way, we're going to look to slide the master in. Got to get the rod in the center of the cylinder. There we go. So it's pretty neat, as you can see. The bracket, you know, it's very nondescript, can't really see it. The master's angled out the way as much as we can. Going to bolt that up from the inside, and then that's in its position. So that's great. About a 6mm plate, tapped for M8 1.25 thread for the studs, and obviously then just drilled out for the bolts. But yeah, nicely moves that out the way from about that position to that. So it's just off center now, and you really can't tell it's been modified. So yeah, that's worked out well. It looks a little like Frankenstein's monster, but I have finished the downpipe. I've tacked it with my awful welding, ready to be welded by a professional. So it kinks off that way, curls round, and then comes kind of back on itself. Under there, it's hard to see. Comes down there, and it flows to the bottom. So, oh great, that's one job done. Obviously it is really close to the slave, master, sorry. I'm going to try and put a heat shield in, but it's so close I don't know how successful I'm going to be, but I'm going to give it a go. But really glad that's done. So one of the other things I'm looking at is this oil drain to come out. The original one I had a straight on fitting, and to get away from this bolt and some other things I was having to rotate it quite far, and then it was sending the hose out sort of straight towards the body. So I've got a 45-degree fitting I've bought, so it's an AN8 fitting with a push on 1/2 inch 13mm on the other end, and I am having to lay the turbo over nearly at a 45-degree, which is a little bit too far, but I'm going to do it. I think it'll be fine. The oil feed still comes in at the top, got your 2 water lines, and then your oil drain. And then if I just take you off the stand quickly, so there's the oil drain now, so it pushes it out and past that nut and then sends it down vertically, which is quite nice. So that's the way I'm going to run the oil drain now, so just a different end fitting. I bought a new actuator rod, so this is 20 centimeters long. It's a 1/4 inch UNF thread, and So check, it can be 6mm, so check what actuator thread you've got. And basically I'm going to be setting up a new actuator position, and I'm going to have to bend this quite a lot. I'm going to need to bend this 90 degrees there to come across, and then measure how far I need to come, and then it's going to be another 90 degrees so I can offset the rod, and then it will bring it out upwards and hopefully in parallel with the wastegate. So much further on in the day, been quite frustrating trying to do this actuator. It was a bit head scratching at one point. So what I've done is, in the face of this cold housing, there's M8 holes, but they weren't quite in the right place, so I've tapped a couple of new M8 holes to put the actuator where I wanted. The trick was going to be with this oil drain, and the wastegate arm is in a different higher place, and I can't put the actuator here because of all the ABS. So what I wanted to do is I wanted to offset the bar, the rod. So I bought a 20 centimeter rod. I went to bend it the first time. My mistake was probably maybe didn't heat it enough, but also I think I was trying to put too much of a bend in. I was trying to do a 90 and I snapped it. So that was a real bad moment for today. So I didn't really know how I was going to get around this. I thought if I can't bend the rod, then I'm going to be in trouble because I can't get round this oil drain. Anyway, so what I've ended up doing is the remaining bit of the new bar I actually put into the actuator, marked, and then did probably more 45 to 45 degree bends. Did them quite early, and it is just missing the oil drain, but obviously I'd already snapped the rod, so it only came to about there. So what I've done, because I need to push on with this, because I need to use the car soon, is I got my old rod, cut it, and I've welded the two together. It's actually gone really well, so there's no problem there. So yeah, all works fine there. So I need to get the exhaust welded up. I needed to rotate the cold housing slightly, so I just took the oil drain off, the oil feed off, got the pliers in on the big C clip and just knocked it down a little bit, so it's probably come from there to there, so it lines up nicely with this again. So yeah, little tweaks like that, absolutely fine. So I've done the actuator today, I've done the exhaust. Yeah, it's actually turned out really well. I've got the downpipe welded up this morning. It's a bit of a monster of the old and new, so obviously new section in here and a new section in here with a V-band clamp. So yeah, that's all done. It's very wibbly wobbly. It's a very tight space to get in there. You can see the different angles that you have to do. So that's done. So now I've got to look at the heat shield, and once the heat shield's done, I think we're rocking and rolling. So obviously it's very tight between here. There's a lot of things here that you'd like to protect from the heat that's coming out here. So I've got this aluminiumized heat shield, very strong that way, wobblier that way, but that way. So what I'm thinking of doing, mounting something like that in this side. It's going to have to be manipulated into these corners and come in out as close as you can, but yeah, I'm going to try and put a riv nut in the body here and put an M6 bolt in there to hold it. You've then got the original shield fixing here. What I want to do is make an L bracket so I can then pick up the side, because that's quite awkward to get to, but if I can make an L bracket there and attach it there as well, I might get away with just two fixings. Have to see how strong it is, but that's what I'm pushing forward with at the moment. So I've moved on a bit. I've been able to bend and cut this shield into something that resembles something useful. In the back there, I put a riv nut into the rear bulkhead and connected it with an M6 bolt, and then I made a little L bracket on the original pickup in the body down here to pick up going sideways. I've trimmed it and bent it over. It's not the prettiest thing in the world, but it makes it stronger. Really close, obviously, all around here. Gonna fiddle with it a little bit more, but I've got that in. I've got the exhaust downpipe in, connected up down the bottom. I'm just about to feed the oil drain down, and then I'm going to place in the cold housing and the turbo. So it's all back together. Yeah, connected everything, all lines, oil drain. This shield seems to maybe just about work. Obviously reconnected all the hoses. been charging the battery, but I've got a jumper on it to give it a little bit of help because it does seem to drain after about 2 weeks, which is a bummer. Right, let's turn it over and see what happens. So I've had a test run on the car. Most things seem absolutely fine. The one thing, or quite a fairly major thing that I was noticing was that I was creating a lot more boost. I accelerated hard, and I know it boosted. I wasn't looking at the time, and it cut. So I think there's a safety cut at around about 15 psi, which is obviously too much. That, you know, more than I want to be putting in. So when I first did the build, I had the green spring in from the Mamba actuator. I then changed the hot housing last year because I changed it from a really cheap part to a Mamba part, and it wasn't creating as much boost, so I put in a yellow spring, which is the one that's in there, so that should create more boost, and it does say up to 14 psi there, so that's too much. So what I want to do today is I want to put the green spring back in, do a bit of testing, and hopefully get it back down to sort of 11, maximum 12 psi, a bit of a safer limit. I do want to check, want to get the app up from the OBD to socket to be able to check air fuel ratio, because I obviously don't want it to be going too lean. I'd rather it be too rich, so I need to check that. But yes, all coming together really well. I haven't put up any of the parts specs for the bits I've changed, but I have updated the spreadsheet with all the parts used. So I've updated it. There's going to be a link down below in the description, so you can go to the spreadsheet. You can see all the parts that you need to turbo your car like this. It's been updated as I've gone along, so obviously I've come across a few issues, but you won't, because I've updated it and I've replaced the parts with the updated and upgraded parts. So yeah, I'm doing all the R&D, and you won't have to. So yeah, no, really happy. One thing people are saying, I got a few comments going, oh, if you change this exhaust exit flange, get rid of the V clamp, you can get a different flange that goes on here. You can't for this one, as far as I can see. They were talking about a different flange pattern. This isn't the one. They were saying it's the same as the Garrett. This isn't it. This is same as like a Howsit, and I believe it might have even been used on some kind of industrial machinery, the turbo setup. But for this, to get the hot housing to fit this turbo and this cold side, this was the only hot side with the right flange to meet the Kraken manifold. It then gave me a little option of what exhaust flange I needed to get, so I had to get this one, and I had to then use a V-clamp. Obviously they're saying that if I didn't have this, it would move it forward. Completely get that, but as far as I can see, they don't do it, so I can't do it on this turbo setup. Obviously, if you want to not have any of these issues, then what I would recommend doing is you can still follow all the other build parts, but I would basically get the Kraken manifold. I would get a is it a 2.6? I'll put in a reference number down here. Not very good at the other turbo groups, but I'll put the recommended turbo, and then it will probably, you'll be able to use the Kraken downpipe as well. So if you spent out on the Kraken manifold or the Kraken downpipe and bought the turbo that it was designed for, then you've solved most of these issues, and you can just follow the rest of the build for the other bits. So that would help you out. But obviously I was trying to do it for a particular budget, and I think even doing it this way, it's still pretty good. I think it's around about the 3,000 mark. Obviously cost of living's picked up some of the prices as well, so it's come up from like 2.5 to around about 3,000. But 3,000 for doing your own turbo kit, that's still pretty good, isn't it? And now you don't have to build your own manifold, so that's got to make it a lot easier for people. Okay, let's crack on with this spring. So just about to open up the actuator. So on this one you take out all these Allen headed bolts. It's under spring pressure, so hold it. So that's the last bolt, and then all it is a spring. So the arm is threaded into the end, The rod is threaded into the end, I mean. It's basically a piston. I'll give that a good clean up. And then what you're left with is obviously the spring. So you can see as you go up in different springs, and there's much harder ones than that, but we're going to put this one back in. Just going to clean up the parts, get it back, and then do some testing on this actuator spring, and hopefully it's brought the PSI down. So down here is your actuator rod. I've obviously changed the spring, and I've just adjusted this. So basically you should put preload on your pin. You shouldn't just put it hole to hole, because it'd be too easy to open the wastegate. So you preload it by screwing this back and then having to push it out to get onto the pin for the wastegate. The amount you do it affects boost, so the more preload you have on it, the longer the wastegate will be held closed, and therefore you'll have more boost. So if you're, for example, if you've got 10 pounds of 10 psi of boost and you want 11, then you'd put slightly more preload on here, so you'd pull this back and it'd be harder to get onto the pin, and then you can do it that way, and you may be able to do the small adjustments to then get 11 psi, so that you can play around with this, and that will play with your boost. You don't have to do anything inside your actuator or on the electronic boost controller. You can literally just play around with the preload, and that can adjust in small increments the amount of PSI you've got. So with that on there, just making it sure it's free. Yeah, nice action there, should be working fine. Get all this back together, do another test run, and see what PSI we're producing. So I changed the actuator spring, so now when I've been out it's boosting up to about 10, but we still have an issue because it seems to be boost creeping now. So it would stay at 10 for a few seconds if you've got your foot hard down, and then it creeps up to about 15 again. So I'm guessing I've got an issue with the wastegate side of things. I came back and I took some of the preload. There was quite a lot of preload I'd put on the rod, so I took off some of that preload, and it allowed the rod to go a little bit further. I thought maybe that might help. It hasn't really. I thought one of the issues was where this exhaust flange goes on, there's not that much room for the wastegate to open, but when I look at the rod movement, it's fine. It's not even getting to the end. So it must be the fact, could be twofold. One, the hole inside the turbo hot housing is too restrictive, and the other is this design doesn't flow those gases straight into the exhaust exit. It has to go across from here and into that lane. So maybe there's a little bit of material I can take out the top of this exhaust flange, but it's absolutely breaking at the moment, so there's going to be nothing I can do probably today. Need to let it cool down, take it all apart again, see if I can port the wastegate a little bit. I had a quick word with the tuner, and you can't tune out boost creep, but you can try and make the tune safe in that boost range, so you're not going too lean and things like that. Obviously you start then thinking, am I making too much power? It's torque that breaks rods, but torque makes power, so, or BHP, so it is all interlinked. But if you can try and make it safe, that if it creeps a little bit it's okay, then that'd be great. But at the moment I'm going to try and get rid of it, or reduce it, and try and have a look at porting that turbo. But yeah, it's a gift that keeps on giving at the moment. Just got to keep going, get your head down, just keep working at it, and hopefully we'll get there in the end. So I've just taken the hot side out. So looking at it straight away, that looks like a decent sized hole for the wastegate. There's not going to be a lot I can do for that. I will try and increase it a bit. One thing I've noticed is this edge, when it comes out of the exhaust manifold, this edge inside the port is very sharp, so I'm going to try and get some of that off, but you have to be mindful of what you can take off in the inside. It has this very odd lip here, which is taking up loads of space. When you think that this area and then this area is so shallow, which again could be the issue, this is stopping so much of that getting across into the exhaust flow. So I think I'll take off some of this, grind that down. It's just the lip, it's not doing anything. But it's a shame there's not a really obvious problem with the port. I think there's just some really sharp edges on the other side if I can get to them. You then have this, which is obviously this is your flapper. It never opens that far, so you're probably looking at about that. And one of the problems I might be coming across is, obviously there's a gasket that's normally there, but is the depth of this area here. It does taper off, so I can probably grind some of this away, mindful of the thickness, and probably take off radius this as well. And that's all I can really do. So I'm just about to embark on version 3 of the exhaust exit flange. I've already done an update video. I'm going to replace it with this one. I'm going to update it so there's not too many videos on the same thing. This is a Kraken manifold with a T25 flange, and the only hot housing I could find that took a TD04 19T Saab Volvo type centre section was this one. I can't remember the details of it. I put it on the link, but it uses a it's not a very used flange type, so it's got a built-in wastegate, goes into this flange here. This is the only one I can find, so this is cast with a V-band clamp on it. And the problem I'm having at the moment, and I'm hoping what I'm going to do is going to solve it, is I'm having boost creep issues. So I normally like to run around about 11-12 psi. Remember, PSI's boost is just a measurement of restriction, so it changes with every setup, so you can't just say 7 PSI for one setup, 12 PSI for another. It's just whatever the engine wants. But what I'm getting is boost creep, so it's going up to about 15 PSI, and then the boost cutting in. Obviously don't like that. One of the issues with boost creep is you can port the wastegate hole, because the wastegate hole can be too small. But I've done that, and one of the issues I believe is this flange, this is just straight across. So when the wastegate opens, it doesn't even open properly. It kind of hits, because imagine this is quite thick as well, so you've only got about that much of an opening, and the wastegate hits it, and then even when the wastegate's not fully open, the gases have got to go right through this tiny little channel across, and then merge into the main exhaust channel. So that's not happening. So I've been able to find a stainless steel flange, just a cutout flange, and then I've got to do a new connector here, and I want to do a merge across, so this is all blended in, so the wastegate gases can get out. Because what I'm thinking is the gas, it can't get rid of enough gases, and that's why the boost is creeping. That's what I'm thinking. And also I want to shorten, you see how far back the exhaust is. Hopefully this whole thing will be shortened, because I won't have a V-clamp in there anymore, and this will all be shortened, pie cuts down, and just be a little bit more room here. So that's the plan. So another issue I was having, so I've just got the front of the turbo off. You can see the downpipe as it goes down there, and I was having on, what am I having on, left-hand corners. There was some movement, and I could feel some vibration, and I believe that flex joint down there was rubbing on the steering shaft. That's my washing done in the washing machine. So another thing is, obviously while I'm redoing this, I'm going to redo the position of this downpipe. I'm going to sort that all out and make sure it doesn't rub there, and hopefully, this being version 3, this will be the last version. We shall see. Very sorry for a messy workbench, but this is what I've got so far. So this is the flange I've bought. I've had it machined out slightly. I'll put the figures of what I had it machined to on the screen. So I've had this machined out slightly to take this, well, it's a reducer to go that way, but obviously I'm enlarging it. I can't go 2.5 in this flange because it's not going to leave enough meat. So what I've done is I think it's 2.25 to 2.5. And then basically I've had that machined to the smaller size of that reducer. And that's going to come out. It's going to go into a 2.5 inch exhaust. And what I want to do, this is your wastegate opening. And what I'm wanting to do is I'm making basically a bit like that. So the gases aren't having to go across and compete to try and get into the flow like that other housing. This should hopefully open out into this dedicated hole and have a little bit better flow going into this. So I'm obviously going to mark this out, cut this tube hole, so obviously this flows into that, and it's going to be something like that. So yeah, that's my rough plan at the moment. Not bad. Hopefully that would be a lot better for the gases coming out. So a little update on the new flange I'm doing. So this one looks like it's got a mouth now. So basically I put this into the flange bit. This is the bit I had machined out to this size. So that slots in. Don't know why it's not slotting in this time, because it always does. There we go. I've got line up my marks. So basically that goes in like that. And then I've made this piece out. I ordered some very expensive oval, 2.5 oval, which is about the right diameter when you do it that way. I'm sure you don't need to do that. I'm sure you could just bend a piece of a pipe. But basically this is the shape I've got so far. So this is the wastegate hole, and this is the normal exhaust. So that's going over like that. It's going to be neatened up when it gets welded, and we're going to push it away from this hole. But roughly, when you hold that like that, that's what you're looking at. So the wastegate doesn't fully open anyway, it opens to about there, but straight away I'm getting gas going straight out on a nice flow into the main exhaust, rather than having to fight across on the other flange and then get into that flow. So hopefully this is going to allow a lot more flow out that way. I've just radiused these edges a little bit, tried to do a little bit of porting there, not very much, just to try and stop it being a sharp edge. And then what I'm going to do is get that all welded up. So that's the new flange, which looks really good. And then I'm going to see if I need to make a whole new downpipe, or whether I can actually just butt the old one up to this. That would be great at the moment, because the less work the better. This is how it fits at the moment. So nothing's welded, so just bolted that up slightly. This is the little bit that's going to come across there. I've measured it so it shouldn't interfere with how I've moved the brake master. So now I've got to see how, obviously normally you have to turn quite quickly down here. The maximum I'm going to be able to turn at the top of that weld. And then I'm going to see if I can get away with what I've already got as an exhaust, just to butt up to that. But that's the kind of thing we're looking at. I think it should flow out this wastegate here a lot better. I cut the V-band off my old exhaust downpipe, cleaned it up a little bit, and then mated it up. It does look like I can use it, so that's what I'm going to do. I'm going to get that all welded up. So I took the exhaust to the welders last night. My friend Hayden did a good job. So this is the old exhaust. Sometimes it can be difficult welding to older bits and stuff, but he's done a good job there. And then this is obviously the piece I made for the wastegate exit, all welded up. So I've just been playing around with the wastegate, because obviously you want the wastegate to open as far as you can. When I first put it on, I was only getting 1/2 inch of travel on the wastegate because it was hitting something. So what I've done is I've gone in, I'll show you in a second, I've gone in and well, you called it porting, but I've ground away some of the excess material inside that I don't need. And now I've got a really good wastegate movement, so I'm really happy with that. So not only is the wastegate movement better, so it should open and the flow's better, but then it's opening straight up into this gallery here that blends into this and should be way better than having to force its way across and then join in on the old one. So yeah, really happy about that. And yeah, I'll just show you the inside of it. Obviously it's nothing pretty, but I've made sure that this pipe doesn't sit proud, so the flange goes up nice. And then this is the wastegate side. I haven't done it for any looks or anything like that, but I've ground it down quite a lot at the bottom, and I've ground it on this inner edge to try and give it a better flow through. And then I was just grinding away at this top part, which is where the flapper opens for the wastegate, just giving a little bit more sealing so it could open properly. I think it's opening really well now, and then the gas is just going to go straight through there. The other gas is going that way, and hopefully it's a much better blend. So yeah, fingers crossed, version 3 is the last one. So trying to give you a look inside the turbo. So this is the hot housing, this is where the propeller spins, or the exhaust propeller spins, and then the shiny bit is the new flange, and then the bit beyond that is that welded bit is the exhaust. So if you just look into this corner, you can see that after porting and things, if I move the wastegate, here it is, see the flapper? It's opening really well, so opening pretty much fully. I don't even know if the rod will get that far, so probably it's going to open to about there, and that's directing it straight into that new flow bit that will push it then into the main exhaust. So yeah, happy with how much that opens. A little bit of wastegate porting, so I haven't increased the hole anymore because I did that last time, but the transition into it, so I've smoothed this transition into the wastegate. So it was pretty much a right angle before, so I've smoothed that, smoothed it on the other side as well, so hopefully that is a better flow as well. So everything's back together. I've got the new flange connecting into the original downpipe. The wastegate is working perfectly, so I've got a 7 psi spring in the actuator just down there, so that's a low spring. So basically to see if it can just control low boost. So I've driven it and it just stays steady at 7 psi, which is fantastic, no boost creep. So that means now that we can use the electronic boost controller, which is hidden just behind there, to basically override that. So now within the software they can make it boost up back up to 12 psi when we want it to. That also means we can probably use boost by gear as well. So for example, maybe keep it at 7 psi in first gear to limit wheel spin, and then allow it to go full boost in the rest of the gears, that type of thing. But really, it's really good. So the downpipe isn't hitting or anywhere near the steering shaft anymore, so that's all good. So I believe version 3 has hopefully cracked it.